morning students, welcome back to mathematics classes. In today's session we will be moving on to the next chapter, that is complex number. Regarding the weightage of the chapter, we shall intimate it to you all later on in my next classes. Now to begin with, first and foremost we shall discuss about the definition of a complex number. If x and y are real numbers and I is an imaginary numbers, then the number of the form x plus I into y is called as a complex number. I repeat that, if x and y are real numbers and I, small I, is an imaginary number, then the number of the form x plus I into y, the number of the form x plus I into y is called as a complex number. X and y are real numbers, I is an imaginary number, then the number of the form x plus I into y is called as a complex number. Here the complex number is denoted by Z, capital Z. What does I stands for? I stands for imaginary number, and the power of I, that is the power of I is equal to, power of I is given by square root of minus 1. If power of I is square root of minus 1, then what is power of I square given by square root of minus 1 into root of minus 1, which implies root of minus 1 whole square, square root and the square get cancels, and what remains? It is just minus 1. Power of I is nothing but root of minus 1, and the power of I square will be what? Minus 1. And what will be I cube? I cube will be minus I. This is all about the definition of a complex number. Moving on to the next definition, how do we represent a complex number? Every complex number consists of two parts. The first part is called the real part and the second part is called as imaginary part. Consider the complex number z is equal to x plus I into y. What does z denotes? It denotes the complex number. What does x denotes? X denotes the real part of the complex number, and this real part of the complex number is denoted by Re of z. Similarly, what does I stands for? It stands for an imaginary number, and here in this definition y represents the imaginary part of the complex number and it is denoted by Im of z. So how do we represent a complex number? It has two parts, one is the real part and one is the imaginary part. The real part of the complex number is denoted by Re of z, and imaginary part of the complex number is written as Im of z. Clear? Next. In a complex number, if the real part is absent or if the real part is 0, then the complex number is said to be purely imaginary. I repeat that, please make a note of it. In a complex number, if the real part is not absent or in case if it is not there, then the complex number becomes purely imaginary. Similarly, if the imaginary part of complex number is not there or if it is absent, then the complex number becomes purely a real complex number. It's the real part of the complex number. That is all about the representation of the complex number. Next, moving on to the next definition, modulus of a complex number. Consider a complex number z equal to x plus I into y. This complex number can be written as x plus I into y or a plus I into b or c plus I into d and so on. However, complex number should contain one part of real number and another part of imaginary number. So here, consider a complex number z is equal to x plus iy. The modulus of a complex number is denoted by mod z and is defined as square root of real part of z whole square plus imaginary part of z whole square. Real part of z whole square plus imaginary part of z whole square. So when you consider z equal to x plus iy, what is real part of z? Modulus z. What is real part of z? That is nothing but x square plus. What is imaginary part of z here? Imaginary part of z is y square. This is all about modulus of a complex number. This is how we represent the modulus of a complex number. Next, moving on to the conjugate of the complex number. What do you mean by conjugate of the complex number? The conjugate of a complex number is obtained by changing the sign of an imaginary part of the complex number. What do you mean by conjugate of the complex number? The conjugate of the complex number is obtained by changing the sign of the imaginary part of the complex number. As mentioned earlier, how do we denote the complex number? It is denoted by z and it is given by x plus I into y. X is called which part of the complex number? Real part. And what is y called? Imaginary part. The conjugate of the complex number is obtained by changing the sign of the imaginary part of the complex number. Here, when you observe, what is imaginary part of the complex number? Sign associated with plus. So we need to change the sign. So it becomes minus. And how do we denote the conjugate of a complex number? We denote the conjugate of a complex number by z bar and is given by x minus I into y. The sign of the imaginary part of a complex number changes. Now, say for example, if z is equal to x minus I into y, complex number are always denoted by x plus iy. In case if you have to find the conjugate of z, which is given as x minus iy, how do we denote the conjugate of z? We denote the conjugate of z as z bar and it is given by x plus I into y. Conjugate we denote by z bar, and how do we obtain the conjugate? By changing the signs of an imaginary number. If the imaginary number is positive, we make it as negative, and if it is negative, we make it as positive, and we denote the conjugate of a complex number by z bar. Moving on to the next topic, we shall discuss with algebra of a complex number. Before I start off with algebra of a complex number, let me tell you what is the power of I. I stands for what? Imaginary number. What is the power of I here? Square root of minus 1 as discussed earlier. And what is the value of I square? It is minus 1. I stands for imaginary number. The power of I is equal to square root of minus 1 and the power of I square is equal to minus 1. So, with respect to algebra of complex number, we have 4 operations. The first one is addition, the second one is subtraction, the third multiplication, and the last one is division. So, we shall discuss the algebra of a complex number one by one. The first operation, we shall discuss about the addition of a complex number. Now, if z1 is equal to a plus I into b and z2 equal to c plus I into d. What does z denotes? Z1 and z2 denotes? It's a complex number. A is the real part of the complex number z1. B is called the imaginary part of the complex number z2. Similarly, C denotes the real part of the complex number z2 and D denotes the imaginary part of the complex number z2. Then we shall solve regarding the addition operation of the complex number. Consider which operation are we speaking about? Addition. So, we shall consider z1 plus z2. Consider z1 plus z2. What is z1? A plus I into B. What operation holds in between these two complex number? An addition operation holds. And what is z2? C plus I into D. Now, start adding these two terms. What do you get? A plus C. Then again you need to add all the terms. That is, the first term is A plus C. You have added the real term. Next you need to add the imaginary term plus IB plus ID, IB plus ID, A plus C plus IB plus ID. With regards to IB plus ID, what can I do? I can take I as common. So what do I get? A plus C plus I times B plus D. What does A plus C represents? It represents the real part of the complex number. And what does B plus D represent? It represents the imaginary part of the complex number. So the real part of the complex number is what? A plus C. And what does imaginary part of a complex number? The imaginary part of a complex number is nothing but B plus D. You can enclose it in the brackets. Implies what? For all Z1, Z2 belongs to Z. Z1 is a complex number, Z2 is also a complex number. Both Z1 and Z2 belongs to a complex number Z. Implies Z1 plus Z2 also belongs to Z. This is all about addition of a complex number. Moving on to the next operation, subtraction of a complex number. Subtraction of a complex number. As the operation itself indicates, what are we supposed to do? We are supposed to subtract. So consider Z1 minus Z2. What is Z1? A plus I into B. A plus I into B. What operation holds in between these two complex number? Minus. What is Z2? C plus I into D. You need to multiply with the signs. What do I get? A plus IB minus C minus I into D. Now grouping the real parts. What is the real part here? A minus C. Grouping the imaginary part. When I group the imaginary part, I will always take plus I as common, and what remains? B minus D. Why do I take plus I as a common term? Because complex number is of the form x plus I into y. In order for me to get x plus I into y, I will be taking plus I as the common factor, and what remains? B minus D. So what is real part of the complex number now? The real part of the complex number is A minus C, and the imaginary part of the complex number is B minus D. What is real part of the complex number? The real part of the complex number is A minus C. What is imaginary part of the complex number? Imaginary part of the complex number is B minus D. So what will be the final conclusion? For all Z1, Z2 belongs to Z implies Z1 minus Z2 also belongs to Z. Z1 is a complex number, Z2 is a complex number, both belongs to a complex number Z implies this operation, that is Z1 minus Z2 also belongs to a complex number at Z. This is all about subtraction of the complex number. Moving on to the next operation of the complex number, that is multiplication of a complex number. Multiplication of a complex number. As discussed earlier, what is the power of I? Square root of minus 1. What is the power of I square? The power of I square is minus 1. And what is the power of I cube? I cube is nothing but minus I. Keeping this in mind, we shall discuss about the multiplication operation of the complex number. As the operation itself indicates, we need to have a product, that is the multiplicative operation. So what do I do? Consider Z1 into Z2. What is Z1? A plus I into B. And what is Z2? C plus I into D. In between these two terms, what operation holds? A multiplicative operation holds. Start multiplying each term. What do I get? AC plus I into AD plus I into BC plus I square BD. Multiply each term. So what do I get here? This is nothing but AC plus IAD plus IBC. What is the power of I square as mentioned earlier? What is the power of I square as mentioned earlier? The power of I square is minus 1. So minus 1 into BD is nothing but minus BD. So when you look at this step, what is the real part of the complex number? The real part of the complex number is AC minus BD. And what is the imaginary part of the complex number? When you take out I as a common term or a common factor, what it remains? AD plus BC. So in this step, what is the real part of the complex number? Real part of the complex number is denoted by RE of Z. Real part of complex number is AC minus BD. And what is imaginary part of the complex number? Imaginary part of complex number is IM of Z. And what is IM of Z? It is nothing but AD plus BC. This is imaginary real part of a complex number, and this is imaginary part of a complex number. So what will be the final conclusion? For all Z1, Z2 belongs to Z implies Z1 into Z2 also belongs to Z. It means the product of two complex number is once again a complex number. It belongs to a complex number. Moving on to the next operation of a complex number, that is division of a complex number. Consider Z1 divided by Z2. Consider Z1 divided by Z2. What is Z1 given by? Z1 is given by A plus I into B. What is Z2 given by? C plus I into D. This is Z1 divided by Z2. Next, what do? We need to rationalize. Rationalizing, we get, you can make a note of it, rationalizing. When you rationalize, the sign of the denominator changes. C plus ID becomes C minus ID divided by C minus ID. So observe here, when you observe the numerator, what do you get? A plus IB into C plus ID. C minus ID. A plus IB into C minus ID. Observe the denominator part. Denominator is of the form A plus B into A minus B. According to the formula, what is A plus B into A minus B? A square minus B square. So this is of the form A plus B into A minus B. A plus B into A minus B is given by A square minus B square. What is A square? C square minus. What is B square? I square D square. Clear? Now start multiplying each term now. When you multiply, what do you get? A into C minus I into AD plus I into BC minus I square BD. Whole thing divided by C square minus I square into D square. C square minus I square into D square. In the working column, make a note of it. What is the power of I square? The power of I square as mentioned earlier is minus 1. Minus into minus will become plus. Similarly, in the denominator, what is the power of I square here? Minus 1. So minus into minus will become plus. So numerator can be rewritten as AC minus I into AD plus I into BC. I square is minus 1, minus into minus will become plus BD. Complete thing divided by C square. I square is minus 1, minus into minus will be plus, and it can be written as plus D square. So observe the numerator. When you observe the numerator, you can group the real part of the complex number. What are all the real part of complex number? AC plus BD. Similarly, group the imaginary part of the complex number. I have your minus AD, I have your plus BC. I will take out plus I as a common factor in order to get the complex number of the form x plus I into y. So if I take out, what do I get? BC minus AD. complete thing divided by c square plus d square. When you observe this step, what is the real part of the complex number? That is nothing but AC plus BD divided by C square plus D square. When you observe the imaginary part of Z, what is the imaginary part of Z in the division operation? BC minus AD divided by C square plus D square. So we shall write what is the real part of Z now. What is the real part of Z? AC plus BD divided by C square plus D square. Similarly, what is imaginary part of Z? Imaginary part of Z is BC minus AD divided by C square plus D square. This is the real part of a complex number. This is the imaginary part of the complex number. So what will be the final conclusion? For all Z1, Z2 belongs to Z, Z1 divided by Z2 also belongs to Z. This is all about the algebra of complex number. So in my next session, we shall pass on to properties of a complex number. So this is all about the algebra of complex number. We have discussed addition, subtraction, multiplication and division. Thank you.